Okay, so according to the poll, I should do some random bug fixing. Let's see if that still applies. Yeah, okay. And so I've already picked some bugs, and I'm gonna start with this one because it looks easy. So the task is to fix scanf, and this is the code that causes a problem, and so I'm gonna paste it here and already remember the bug number, and I will test if that's actually a real issue. Wrong. Okay. Now I would like to have the chat on the side, but I don't know how that would work. Let's see if somebody Alright, okay, so never mind. Okay, so the issue here is that test is evaluated twice, and so it produces twice this someone called me message, and the fix should be that we introduce a temp variable that stores the input in a let binding. Yeah, and I've written this code quite some time ago, and so I don't really know how it works anymore. Okay, so this is scan P, we are looking for scan F. Alright, so this input thingy here is used all the time, and what we need to do is to fix this statement list here, to introduce a new var statement, or I hope we have also a new let statement to bind this input. So yeah, we need a new consum, and yeah, let's try it. Import is an let, and we call it input, and we introduce here. And by the way, Dom, this is where the shadowing hopefully works and doesn't produce a new bug. New var statement, and this var statement is oh yeah, okay, I'm wrong. I need to bind this input to the old input, so I need to rename it anyway. Too bad. And let's see if it works. Okay, so the compiler is a bit picky here. I'm not sure if we have a new, yeah, okay. That was easy, right? Now let's see if the tests still work. and I hope yeah, there are a couple of assertions here. They all continue to work. Yes, I will rename it to a proper thing soon. Now let me see if I can. This is actually annoying here because I cannot just put this in a do assertion and in the when is main module here. So either I can be lazy and call it a bug that is which has no chance of ever occurring again, or I need to figure out how to make this a test case that works for do assert. But I think it's simple enough, right? What we need to do is to introduce a counter here, and we're gonna increment it on each call, and we're gonna check that the count is in fact only 1. All right. All right, okay. And so, okay, now we need to rename this input B to something sane. Let's see. Yeah, I think I will do it properly and name it I don't know, from input or imp, and I only want to match whole words, and I'm going to replace it here, 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 and here. And now we can keep the old nice name, old, and see if it still works. Okay. And so I don't know, some white space issue probably here. And I'm gonna commit my change. Okay, one bug. Fewer. So this is the other bug that I've picked because it's marked as high priority. So this doesn't produce a GC safety warning according to Vegansk, but it should, because otherwise our GC safety might be broken and you might get random crashes. Okay, so this looks very tricky. I don't know if I will be able to fix it, but I will switch to some other bug if I cannot do it in time to not to bore you too much. Okay, so I have a handler A, and this is GC safe, And so this is not GC safe, and because it references this global res here, which is a string, and string is garbage collected memory, at least for now, and so it will it shouldn't compile. So this is this do notation, and according to him, if this is put into its separate proc, then of course the compiler complains. Now first thing we'll do is to see whether this bug is still valid. So yes, it compiles, but shouldn't. Okay, and so the first thing I want to check is this actually the fault of the do notation, or is it something else? So I will rewrite this to use the different anonymous proc notation here, and yeah, still an issue. Then the other thing, because this is actually not idiomatic nym code, let's see if that somehow makes a difference, and it doesn't. Okay, so actually every anonymous proc is affected by this bug. Okay, we can simplify it further though. We can say, okay, this handler here is of this type, and I think I need the parentheses around this here to make the compiler happy. Still an issue. Actually, we should check if the generics that are involved here are actually to blame or not. So let's see. So I'm gonna create another proc, like I don't know, take a callback to proc a string is safe. And just simply invokes foo with a string. And yeah. I should disable autocomplete, by the way, because it's just annoying. Still a problem, and generics are not involved here, and it also says it's not what? It's declared but not used. Lie, it's used here. Stupid. So I might fix that as well, even though I think that's actually a nym suggest problem again, because let's see, so the compiler here actually says only actor is declared but not used, and that is correct. So that's probably caused by running nym suggest in a different thread that doesn't really get the latest version of this code, and it used to not to be used, and so back then nym suggest was correct. Okay, Oh yeah, so the GC safety handling is done in the compiler in the file called xampus2, which means actually it's the second pass of semantic checking, which deals with everything that comes after symbol lookups and type inference, really, and so the effects are inferred later. Okay, so what's the issue again? So we have this anonymous proc here that is not checked at all. So we have this track proc here, which does all sorts of things, and let's perhaps look at the comment. So it says this performs effect and exception tracking. That's still correct. Usage before definition checking. That's right. Invalid usages of compile time magics. Yeah, well, not implemented. That's another open issue, in fact. Checks for invalid usages of nimnode. That's actually this is done in a later phase of the compiler. Later we'll do an effect analysis. No, that won't be done. Yeah, this is actually also not required anymore. I mean, there's code that does that, which is slightly buggy. And we have some ideas of what the effect system should look like, and these are all outdated. And so I'm going to remove this comment. Okay, so what does it do? It detects effects and exceptions and usage before definition. All right, so let's go to this track again. So this is actually a call, and it checks whether the call produces new effects for this thing that is currently tracked. And the tracking actually works on a proc by proc basis, so a full proc is checked and then the other proc is checked. And I think the issue here is that such thing as a do is actually not checked. So this section here tells us that we shouldn't recurse. So if I have a proc foo, and then there's some nice body, and there's also an inner proc with a body, then the idea here is we check foo and only its body. We don't want to check inner because that's done separately. So we shouldn't recurse into this inner proc here. So that's why all these declarative statements here actually just an empty discard. Okay, so we have this track. Usually you can read the compiler from bottom to top. So we have this track proc here that initializes the effect tracking and then tracks the body of the proc. So, and the question now is, where is track proc called? And there's actually only a single usage in this transf transformation path, and it's actually behind a when, so it could be disabled, but of course now every piece of NIM code depends on this effect tracking, but back in the days it was novel, and I had a simple way to disable this whole path over the AST. Okay. Is it? Can you hear me clearly? No reply. So GG is just an alias for nimgrep because I use it all the time. Okay, so we have this transform body, and well, I said it's probably a hard bug because transform body is called for every proc, even anonymous procs, because otherwise you couldn't even use a for loop in these anonymous procs. So that would have been caught many years ago already. Let's think. Okay, so there are a couple of usages. So this is the semantic checking for statements, and I think there's somewhere anonymous proc. Okay. So what we can do is we can just add some debugging to the compiler and see. So how about this? I produce an echo and make it output what it's tracking, and since this is an anonymous proc, we will use the line number here instead of the name. So as info, and then I'm gonna use conf-temp to build a temporary version of the compiler with this change applied here, with this echo applied here, and we'll see what it says. And I should probably have okay. So these are the interesting statements. So it tracks line 7, this guy. It tracks line 11, which is this guy. It tracks line 14, which is this guy, and then it tracks line 17. So I'm wrong. I thought this isn't checked, but it is checked. It's just that this constraint here on the proc type isn't checked. So probably the compiler will say, okay, this guy is GC unsafe, but it has the proper type signature, and so it will work. And I said, okay. And in fact, I've already told you the explanation in the beginning. This pass here runs after symbol lookup and type checking. And the problem here is that we have a type violation. So the problem here is actually that we need to check the types. So yeah, this is gonna be tricky probably. So I also showed you this section here. What we need to do is not just merge the effects of so this is a call, right? So a function call. We need to check if there is a violation of these effects actually occurring here. And I guess the code is only concerned with merging all these effects together, so eventually take callback will be marked as non-GC safe, but that's not the problem. The problem is it says I need a GC safe proc, and I got one that is not GC safe. The other problem that could be okay. Okay, let's see. So in the call we iterate over every argument somewhere here, track operand, and we need to check if this guy here, which is the argument, actually fulfills the contract that the parameter type here says. So track operand, actually we can just add a new condition here, I think. So if the param type is not nil and is actually a proc, and we have TFGC safe and param type flags, so which continue to check what's the argument is just n. Okay. We need to produce an error message, and the error message should be like I don't know, is not GC safe. I doubt this works. Huh? What's the problem? Yes. Oh yeah. Okay. I told you. Let's see if we get here actually. Yes, that's good. So this part of the logic is works correctly. But this isn't. Yeah. Any ideas? Yeah. No. So apparently and type was annotated to C safe. I know. So I suppose the compiler in its eternal wisdom noticed that this is actually not the same here, and it did a conversion of this type into this type already. And so we can skip this closure. Okay, let's see if that works. Yes, it works. Okay. So this is a fix. Let's see if the compiler still bootstraps with this change. And so this will be in fact a breaking change, right? Because code that used to compile doesn't compile anymore. Of course, it's just a bug fix, but most of these code breakages are actually caused by bug fixes. So the question is, you can also use mark GC unsafe here. Well, but that wouldn't be correct, because the marking is concerned with how to put it? This mark GC unsafe thing is actually about inferring that this is unsafe and something else is safe, etc. What we are what we are fixing here is just a missing type check. And I don't want to mess up the marking logic. The marking logic itself is correct. It's just when things are marked differently than the check was missing, that these actually are declarations that fundamentally are incompatible. So I would actually want to leave it at that. There is I think I keep forgetting these things, but TT is my alias for Testament, the testing framework, and we have a couple of tests about this effect system, and so these are all green already, or these are still green, and so I want to write a test case now for this, and I will push it to the Travis check, and tomorrow I will get an email if there was some other test that broke. So I could run the full test suite here, but that would take an hour or so, and I don't want to waste this energy. So I have my tests in different categories, and I'm only testing the categories that apply. But that said, I think we should also test async, because, well, yeah, because async is obviously concerned with these GC safe G issues. Yeah, okay, everything is broken. So let's see. It's not GC safe. So the error is an async macro. Wow, this works. Cool. I didn't know this was possible. Excellent. Yes, so this is I see. So this is actually forced to be GC safe, even though it's not. So we need to add something to our test, and that is, are we in this GC safety override section? Because if so, we should suppress this error message. And is and in enforced GC safe is the name. Okay. Tracked. Yeah, okay. So again, let's test if it's still errors for our bug. Yes, it does. And now let's test async again. Seems to be fine. Okay, what else? Assignment and result variables generates generic resets. Yeah, that's probably a bit boring, perhaps. Let's see. What is this? Have good first issue. Yeah, whatever. I don't remember. I probably there's a lag. I looked up the name in enforced GC safe. I thought also the autocompletion suggested it to me, but actually I scrolled up here and well, I know it's a bool or something like that, and in enforced GC safe is obviously the thing I was looking for. Don't know. So guys, look for bugs, send me a link to send me something interesting to fix. Problem with simple derived value and concept. Yeah, that's a hurry business. And that's actually a feature request. And by the way, these max split parameters for every fucking proc in proc utils is just it's nonsense, because it's the old I cannot parse strings, and so I need tons and tons of helpers to help me with string parsing, and oh god, parsing strings is not hard. If you cannot do it, learn it. Should we do another effect system? Main thread var not GC safe. Lots and lots of stuff. Is that actually a bug? Yeah, but that's not GC safe. I mean, that's probably not a bug. String browse. Okay. Codegen bug. Alright, I'm gonna fix that. But what is this? I mean, am I supposed to clone this shit? Yeah. Can't you write a test case? I mean, it's not. I need to write the test case anyway to add it to the tests. Nice session. Yeah, I doubt it, but thanks. Look down in this issue. Oh yeah, that's the M items bug. Okay, alright. I gave that one a hurry because I think it's hard. But it's, oh yeah, I already said it. Hard to fix. Okay, I'll give it a shot. First, are these tests done? Yeah, okay. So I still need to fix this, finish this one, right? So okay, all right. So let's see. There is an effects test. This one here, and I'm gonna add, and now I need a name for a test, and these tests should all start with a T, because then the tester automatically picks them up. So this is GC safe to name, I think. And usually I copy this discard section from somewhere else, because I never know if it's error message or something else. So I think I'll take my my reduced test case. I can leave out the file. So the error message should actually be, what is this here? Yes, maybe it's a completely different issue, but I will fix an issue. So don't complain. This is named random issues. So this is actually a pretty shitty error message because it transposed the string literal into these things here, and so this will be a different message on Unix, and so I will watch out for this and use ABC instead here. And the error is in line 11. And let's see if this test is green. What? That's not good. That means oh yeah, there. I see the problem. So actually, you can use triple singly quoted things in the error message here, because we also use the double quotes for the discard already, and I think this should fix the problem. And I need an issue number, so this is actually yeah, you documented the test spec, but it's not like I'm reading the documentation again and again and again. There's a 4-second delay. Yes, but isn't it helpful if the proc body is displayed in the call? Yeah, I will. So this is bug 5620. If you have these many bugs, either your software sucks or is quite successful. So let's look at the diff. Yeah, okay. Actually, I will do another test, and that is check for Linux that async dispatch still compiles. I knew it. Oh no. Async macro. But that's the same. I don't really understand that one. But I just tested all the async tests and they were green. Well, okay, it's an instantiation from here, so this is async dispatch. Why doesn't work anymore? I think there must be a slash in there so that I can click on the file name. So does read all is not GC safe anymore? Why? And why are these tests green? I don't understand it. Can anybody help me? Maybe it's just nim check. Yeah, completely mysterious. What? Yeah, okay. Probably I forgot to. Yeah, I don't understand it. I mean, maybe the tester uses a different nim binary for testing, but still, why was it red before that then? So the question is, should I actually push this, or is it too fragile? Dominic. Check Jester if it works with your changes. No. But I have the crucial parts of Jester as a test in, I think, templates. So I will check that instead. Okay, and so I think that's somehow finished. So this bug, value expression, okay. Oh, okay, these are all green. So what is the fix again? This one. Okay. So bug 4910. There is a foo, and it doesn't compile with C++ because C++ is sometimes annoying. Yes, okay. So let's see. The produced code, no. The produced code is somewhere in line 91. No. What? Oh, I'm in the wrong file. Still doesn't really. Oh, that's still the wrong file. I have too many files named temp. Okay, so we have this T here, and we rebind it, and since it's a reference in C++, it cannot be rebound. So maybe I should explain the problem a bit more in depth. So does that work? Yeah. The issue here is that we have this iterator mItems, which is a mutable item, so I'm allowed to mutate this thing here, and this is done with this var t here. So I get an array that is variable, and it produces an element that is also mutable, and I yield this. And for C, we translate this var t into a pointer to t, and I'm allowed to do anything I want to with a pointer. But for C++, to get better interoperability with C++, we produce instead this this t ampersand, which is a reference to t but not a pointer to t. And C++ is picky about these references, so I think it's only allowed to bind this once. So I can do this in C++, but I cannot split this up into this, and I also cannot rebind it. So after some other statements, I cannot set the x to z eventually. And so probably what we need to do here is to detect whether we have these rebindings for an ampersand, and if we do, we need to stick to the pointer translation. Yes, so the translation from nim types into C++ types is done in the CCG types module, which is C code generator types, and it's very complex, but I'm actually already at the right spot here. So I have a var in nim, and if tf var is pointer is not in the flags, I will produce an ampersand and not the star, and if I'm compiling to C++. So we probably need a way to get this flag var is actually a pointer into the type's flags, and then all the other logic in the compiler will make it work. Let's see. This is actually the only usage, but let's ask nimgrep. And we are concerned about the backend here, so there are a couple of problems here in a couple of usages in the backend, and we set this flag in the front end, and this is so cool, but it doesn't go to the right line number. So there's some logic to detect whether this var can be an ampersand or a star, and maybe we need to improve this logic here. So actually this is assigned to the result variable. So if I have in the nim code something like result is equals to blah blah blah, then the logic says something like this cannot be a var, a C++ var, which is actually kind of confusing, but I had my reasons. Now, how do I... What we can do is, I don't know. So what we are actually concerned about the... I mean, it's not visible here, but we are actually concerned about assignments. So if there is an assignment, or if there's multiple assignments to this thing, then it's not possible to translate it into a C++ reference. And we do not really have a counter for that. So it's not like I can just ask any variable how often is it assigned to. The compiler doesn't know. Any ideas? Maybe we can say any assignment cannot be merged with a declaration, and so any assignment to a var can actually be marked as this thing here. So then I would only need to remove this condition here. No, this is wrong, but I could I need to split it up. So for the result step we need to do these things, but for everything, we want to mark the type as dangerous for C++. Yeah. Actually, the error, well, the error message changed, right? Because now, now too many of these instances are affected. But that's the system module, the other, and this is another issue I should fix. I mean, what's this successfully? Hardly. This is actually a regression. The compiler used to do this correctly and then somebody patched it. Okay, but I'm assuming that, well, I can actually look at the code. Yeah, see, now it's a star in here and it can do all these ugly but correct things. Is it actually correct? Oh yeah. So in theory it works, it's just that it's too aggressive and other stuff fails now with this change. I might be able to cheat and so okay, it used to be the case for result, and we also want to do it for var, so for a for variable, and the other problems that came up here are actually referring to parameters. So this is of course still a hack because it's not just it's not just for vars, but at least it's better than it used to be, right? And so maybe I should go with this solution for now. And in fact, I should also get to to one file apply to see if it's breaking other places. Are you still referring to the the C++ code generation bug? Them is not replying. Yeah, well, it's not like we haven't any tests, so actually let's recompile. Oh, I also need to add a comment here telling that this is still not correct. We cannot. Actually, maybe it's just wrong for parameters, and all the others. Well, let's test it in this way now. Yeah, okay, that's just on my machine. My local machine has no Jester, and so this test fails. And the other C++ test cases seem to continue to work. You should ask me an IRC and then it's way faster. Yeah, probably. So maybe, I mean, it's still... What's the bug number again? So this comment is correct anyway, and I think the logic is better spelled as if it's not a parameter. Yeah, it's just okay, this still works, and hopefully the tests are still green, except the Jester. Yes, my voice is all weird and echoing. Sorry, I don't know why. I should probably quit soon. I mean, it's 1.5 hours already. The tests are mostly green, and I will now just add this to the test suite and stop for today. And the next time, I guess I will show you how to write NimPretty, a pretty printer for Nim, so that yeah, I don't know, so that people can type code without thinking and it's formatted for them properly. There's a default test. I'm looking for a test where I can sneak this new test into, so that, yeah, probably. And let's see if that's still green. It stopped. Okay. What? I don't want to change system name. This is okay. Probably tomorrow there will be new bugs telling me about all the regressions that my fixes cause, but that's life. Actually, let's see. What? Untracked working tree files. Shouldn't it be tracked? Yeah, that's all old stuff. Now I'm a bit concerned. I thought I worked from the most recent NIM version, but apparently I didn't. So I'll probably test async again, and it's still green. That's okay. So Dom says I shouldn't quit, but it's late and I fixed 3 bugs, so maybe give me another bug and I will take a look and decide if it's easy enough or not, but my beer is almost empty, by the way, so probably not much time left. Data. No, it's not data write tracking. It's actually data flow analysis. Does it? Yeah, so my file says it correctly. Why don't I push my changes? Even the async tests are actually quite long and annoying, but they're also good. I mean, they test really many different things, and usually if these tests are green, everything else is green as well. Okay, I asked for more bugs and got none, so I will go to the high priority bugs again, see if there's something I want to fix. Oh, that's an easy one. Maybe I should fix that. And do I know if I will be streaming the next time? No, I have no clue. That said, it's Saturday night and tomorrow is Sunday night, so maybe I could stream tomorrow again. This one is an easy one, but should I really do easy bugs? I mean, easy bugs are for other people. And this one, yeah, I will take a look at this one because actually that's pretty bad. So what does it do? Yeah, what dilib? I mean, client username RTL category DLL. Okay. Test DLL client name. And it's yeah, so that's actually the reported bug. That should be easy. So there in NIM there are way too many things to configure things. Way too many ways to configure things. So you can compile with threads on, with threads off. You compile the standard library into a shared library. You can compile it to be embedded into your executable directly. You can compile in debug mode or release mode, etc. And occasionally there are combinations that are not tested and so don't compile. But this time it even got the line number correct. This is so cool. Okay. So this implementation is expected, but it's missing. And so the actually the implementation is in a file called alloc_nym. Here it is, and I'm not so sure. So this is not in a when statement or something. Yes, yeah, okay. I think so this is NIM's memory allocator, by the way, and the garbage collector is built on top of this memory allocator. And recently I noticed that it's much faster than sysmalloc, for at least for the tests that I did. Anyway, so if we compile if we compile using the nym_rtl.dll, then the memory allocator is not compiled because it's taken from this nym_rtl shared library instead, because that's how it should work, right? So all the DLLs need to share the same memory manager so that you can send memory from one DLL to another. And to accomplish that, this memory manager is part of this nym_rtl file. And so this complete file here, alloc_nym, is not compiled when we build against the DLL. So I think I will be able to show this. Okay, let's see. There should be, so this include alloc. Where is this? Okay, let's ask nym_grab. So actually I want full words, alloc, and in system. Yeah, that's not really good enough. Oh yeah. Okay, 504. Yes, okay. So it's included. And nym also has options to use Bohm's garbage collector, nym's garbage collector, go's garbage collector, no garbage collector, mark and sweep garbage collector, an incremental mark and sweep garbage collector, a reference counting garbage collector, etc. And so this mmdis is actually memory manager dispatcher. So the logic to deal with this shit is in this file actually. And there are also lots of tuning options and debug options. So for example, yeah. So this is not related to the topic, but it's interesting for you. So actually you can tell, yeah, I want to debug the GC. I want to log what the GC is doing. I want to trace what it's doing, and these are not well defined, so they change from time to time. So don't ask me what the difference is between debug and trace. Actually, I know the difference, but so the difference in debug is just lots and lots of assertions about its logic, and tracing is actually like, okay, this piece of memory was allocated and now it's deallocated and now it's deallocated again, so that's obviously a bug. So this is what the tracing is about. So then we can say, okay, stress test the cycle collector, or stress test the garbage collector. So always, so every allocation should trigger a GC run to be able to find bugs. Then we can also say, okay, detect memory leaks, detect if freed memory is actually accessed, and these are, well, there are even more. I don't want to explain them all. Okay, so if defined no GC, that's not what we are after. Regions is not what we are after. Well, I think, I'm not sure, but let's see. Okay, so this is the only place where the dispatcher is actually included, and it's in a long when section, and this when section should deal with this DLL logic. If not that, then I'm quite lost. No, it's just when defined J, not defined JS. I thought it were in such a thing as username RTL, but apparently it's not. There is another file in system, but I don't really remember its name. Oh yeah, it's include RTL. So here is part of this logic for DLL building. So if there's a defined username RTL, then the pragma RTL is actually an import. If it's create this DLL, then it's actually an export. Makes sense, right? So you build the standard library as a DLL, and then you use it. Oh, there's this app type lib, and I think that's what happens. No. And so the condition is defined use RTL. I'm really getting tired. So people tell me the tests are red. Yeah, I mean that was expected. HTTP client is not GC safe, but on the other hand, maybe it really isn't GC safe, and it's only that we detect it now. What's the one again? Yeah, I mean this on progress changed. There's actually, oh no. I mean, okay, it's declared as GC safe. And let's see. To upper is deprecated. So yeah, the compiler complains it's not GC safe, but it should be because it's declared as GC safe. I see, but it's wrapped in this generic here, and my fix doesn't consider generics, and so it fails. Okay, that should be easy enough. I'm still not fixed. There's some message. So many edge cases. Take a rest and fix it tomorrow. Yeah, maybe. But why is it not GC safe? Actually, I should have used this guy, I guess, because it could also be side effect free, which implies GC safety. Not GC safe. What? I see. Yeah, so I'm testing if it's actually triggered by this generic or not. It is. It is the generic. Okay. Yeah. But why? Is it... Maybe it's the other way around. Maybe no. Yeah, maybe it's this conversion again, and this time the conversion skips it. Actually, let's see. Let's see. Let's first check if is there actually something skipped here or not. And yeah, no. So there is no conversion that is skipped here. But I think I'll simply I don't know. I'm trying to ensure that the instantiation of a generic proc gets the same type flags as the original one, and see if it makes a difference here. No. Alright guys, I think I will leave it at that and continue tomorrow, and we'll fix this regression and hopefully also this DLL bug. Alright, I hope you enjoyed it. It was my first live session, in fact, and there will be more to come, and see you.